It's 6 o'clock. You ready to start? Monday off next week. Get this thing done and then start your weekend. All right. I know there's some questions on homework 2. Let me address those in a minute. I thought we'd go ahead and watch a couple of videos to start the class off. See what you might be able to do with the stuff you're learning here. Really, and I was talking to a student, I guess it was last class or so, about the class and the content. And really, the purpose of this class is not so much for you to learn ladder logic, as much as for you to learn how to think. Okay? Thinking in terms of bits and bytes and logic is very important. It's very useful. And it'll help you out no matter what type of automation and control you go into. So let me show you a few of the things that can be done in industry with controls. Basically, the idea is how do you automate stuff. So this is a whole potato sorter. What they're doing is removing junk from the potatoes. So you've got a stream of potatoes and you want to remove rocks and glass and whatever else is not a potato. Now, being a corporate video, there may be some cheesy music that's required to go with it, right? That seems like it usually goes. Now this is a demonstration machine. It's just taking the potatoes over and over through the same cycle, but it's showing you that it can sort them out from the debris. I'll show you a few slow motion clips here in a moment. Now the system uses vision. It has a vision camera, so it can recognize things. Why? I think they were trying to hide some proprietary things or something. I don't know. And now here it is in slow motion. So there's a potato that has to be removed for rework. And the vision system and the mechanical system are clicking on it. They can sort them.
Turn them.
I can't see it. Can you guys see it? Is that better? Okay. You want me to rewind it a bit? You see the golf ball is getting sorted out. There's a small rock. A large rock too, I believe. They've got a whole bank of fingers so they can raise whichever finger they want in order to remove the debris. You can see all the rework and the junk comes out on one side and the good potatoes come out on the other. Pardon?
There was one bad one, that good bunch we saw.
I'm sorry, couldn't you?
There was a bad potato and a good one.
It's not
Was
100%
it?
accurate.
Okay, so it may not be 100%, but anyway,
It's not good enough. It's not good.
My point in showing you this stuff is that vision systems are becoming more and more common. Here's another vision system, and one of the things I'm going to do is order a small camera, and I'm not sure what all we'll be able to do with it. It's fairly inexpensive. It's under $100, but it's an entry-level vision system. It's not industrial in nature, but it follows the same principles. Anybody work for Key Electronics in Jeffersonville? Okay. Well, visited them, and I believe they still have it, correct me if I'm wrong, don't they have a vision system where they check circuit ports, make sure that all the components are populated properly? I mean, if you think about it, especially the ECTs know that on a typical circuit board, it's easy to have 1,000 components, right? That's not a huge board, really. So inspecting 1,000 components once they've been automatically placed and automatically soldered is a huge job. So you can have, if you can have an automated vision system do that task, then you can get it done quicker and more accurately. Now the way that system works is it identifies problem areas and highlights them on a screen basically where an operator can take a board, look at it, check it, and make sure everything's okay. Or reject it or rework it. Here's a vision system. It's recognizing playing cards. Over here is the actual image of what the camera's seeing, and over here is the software recognizing the card. Now, in just a minute, they will pan to the mechanical system and see how quickly these cards are going past. Same set of cards over and over because they're just glued to a rotating drum. So there's the camera. There's light on the drum. So that's the camera. So I'll pan to the drum in a moment. There's light shining on the drum so the camera can get enough image data. And you can see the drum's rotating pretty quickly. So the vision system is capable of recognizing the card quicker than the laptop is displaying the card that's being recognized. That's pretty impressive. And that's an old video. There are many different manufacturers and distributors of vision systems. Some of the systems have. We'll watch more of these later. But some of the vision systems have crossing on board of the camera, so you can just have an on-off type output come out of the camera to have a true or false signal. For example, some companies used vision systems for inspecting incandescent light bulbs. So the incandescent light bulb comes by, and the vision system looks at the light bulb and determines whether or not the filament is intact. If the filament's not intact, then it's rejected. It was an interesting application. But anyway, you can then send that to a PLC as an on-off signal saying, yes, it's good, no, it's bad, okay, rather than actually sending image data. There's other videos here. They're fun to watch. They're interesting. But we'll watch those a little bit later. I want to show you guys some new commands. Here come the lights. You ready? So you've seen coils and you've seen switches essentially, although that's really not the right name. You've seen contacts and you've seen switches. What about timers? Are there any applications where a timer would be needed? Well, actually there is, and a stoplight is probably one of the simplest examples or most common example where you can see that a timer is needed. Now, sometimes people will try to use a timer in a PLC when they should use a sensor. For example, remember the silo simulator we played with last time? We could have put a timer in that so that after the level sensor goes off, we don't stop the box until a certain amount of time has passed. That way, if the proc sensor is cleared, we would never stop the full box. Does that make sense? And the problem with that is that what we really should do is remember that an event has occurred, or have a sensor that detects that the box is still full. In other words, two different level sensors, so we can keep track of the fact that we have a full box. Okay? So using a timer is a mistake that a lot of people will make when they either should remember that an event has occurred or add another sensor. Okay, for example, you might say, well, the part comes into the process and it needs to stop here, but I don't have a sensor to tell me that the part's actually in position, but I do have a sensor that detects the part as it comes into the process. So the part should come to the correct position in about 5 seconds, so I'm going to put a 5-second timer on this sensor. So after the first sensor is triggered, the part comes in, it should be in place in 5 seconds. The problem with should be is that sometimes it doesn't happen. Okay? So what you really need is another sensor to say, yes, the part is actually in place. So be careful when you use timers. Timers should only be used to track time, not to assume that something has happened. Okay? So anyway, I'll show you how to use timers to operate the stoplight. Now, when you're programming something like this, it's usually easiest to start with a small part of it and not make the whole program at once. There's different ways of approaching programming. But for this problem, I'm going to approach it by talking about what happens in this cycle, or what I want to have happen in the cycle. Now, let's see, probably, I don't have a yellow marker, it wouldn't show up anyway, but I do have red and green. So let me create a timeline in black. And I'm going to define how I want this cycle to operate. So I'll start with red. Now let's see, I'm going to work with the right-hand side. So these lights over here first, and decide exactly what I want to have happen. So let's make the red light come on, and this will be a time axis here. Let's make the red light come on for, I don't know, let's say 30 seconds. What comes after red? So let's have the green light come on, and if we had the green light come on for 30 seconds, that would not be a good idea. Because if the green light was on for 30 seconds over here, we want it to be on for 30 seconds over here, right? We have to have some amount of time for the yellow light to be on as well, okay? So let's make this, say, 25 seconds. Tell you what, let's do it this way. The seconds over here is the units. So I don't have to write seconds over and over again. So the last color I have, unfortunately, is blue. We'll have to use that for yellow, so my apologies, but that's all I've got. So to make everything match, it looks to me like that we should have 5 seconds of yellow on the right side. Now, how would the other side, how would the left-hand side? How should we have the left side operate? Well, we should definitely have red when the right-hand side is either green or yellow. And what comes before red? Yellow. So we have to have 5 seconds of yellow before the 30 seconds of red. And that would leave us 25 seconds for the green. Okay, so both sides are treated equally. And we haven't even talked about a traffic sensor. There is a traffic sensor right here. These boxes sense when a car is in location. So we could use that, but I'm not focusing on that. I'm not going to program a real traffic light right now, because what I'm really trying to do is teach you guys timers. Okay, so it's obviously going to be timers in this application. All right, now, one more thing about this. This scheme is not a real scheme, right? Because if you had yellow turn off right when red turns off over here, and then red comes on this side, green comes on this side, there's going to be some collisions. Because there has to be some red lamp overlap so that any car in the intersection has some time to clear the intersection. We're also not going to worry about that for right now. Okay? The reason is that once I've taught you how timers work, I'm going to teach you how cascading timers work. Then I'll show you how to perform this whole stoplight with one single timer. Make the map any way you want. But let's start off working with timers, and we'll start off just trying to make a light be on or off for a certain amount of time. So if you want to follow along, you can. If not, I'll post all of this. So I clicked over on the timers/counters tab. The reason that timers and counters are together is because they're very similar commands. Okay, one counts time, the other one counts events. That's really the only difference between time increments automatically, whereas events or triggers of sensors are asynchronous typically. In other words, they happen sort of at random. Okay? Anyway, so over on timers and counters, there are 3 types of timers. There's T-on, T-off, and retentive timers. The most commonly used timer is T-on and retentive timers. But T-off is also handy in some situations. I'm just going to start off with T-on, show you what it does, then you'll understand the other two, because they're just slight variations on it. So if you drag the block over, it looks different than any command we've seen so far because it's a lot bigger, right? It's not just a simple coil, it's not just a simple set of contacts, it's a big block, and you have to put a lot of information in here. Now, one of the questions you have to, or one of the things you have to program in here is how long you want the timer to run. Now, in Logix Pro, this simulator, the time base, the only time base we have available is 0.1 seconds. What the heck is that? Well, you're going to count up units of time. You have to decide what those units will be. Are we counting hours, seconds, minutes? What is this? Well, in normal RS Logix, you can choose the time base to be, I forgot, I think it goes from a millisecond up to maybe tens of seconds. I don't remember right now, but you can choose the time base. In Logix Pro, all we have is 0.1 seconds. So we only have 1/10 of a second. Those are the only units that we can use. We can't change it, okay? So the time base is something you would normally adjust. Let's say you wanted to count up an hour's worth of time. Well, you don't want to count that in 1/10 of a second, right? You count it in large units of time. Just like if you want to measure a part that's this big, you don't measure it in miles, right? You measure it in fractions of an inch. Same thing. So I said that I want the red lamp to be on for 30 seconds, so let's see if we can make that happen. So I'm going to double click on timer first of all. You have to give it a name. So T:0 is the name I will give this. Notice that Logix Pro changes it over to T4:0. The reason for that is that file number 4 is the timers file. And in that file is where all the information for the timers are stored. What kind of information? Well, time base for one, preset for another, and accumulation. Now, what are preset and accumulation? Well, preset is just how much time you want it to add up. Okay? Before it triggers something to happen. Because what it'll do is after it has accumulated as much time as the preset that you program, it'll enable the done bit. Now that sounds complicated, it's really not. Once you see it work, you'll understand. So if we're counting in tenths of a second, I'd like to count for 30 seconds. How many tenths of a second does it take to make up 30 seconds? 300. So what I'm going to put in the preset is 300. I'm not going to change the accumulation value because the accumulation value is just where that command is going to keep track of how much time has elapsed. Okay? And no time has elapsed. Now if I were to start this and run it, T on, this timer would simply turn on. Okay? Now, like I said, I'm going to try and make the red lamp turn on for 30 seconds. So let me drag the address of the red lamp. This is the right red. And once again, if I were to run this right now, there's no conditions for the right red lamp to be on. It would just turn on when I ran it. But what I'm going to do, notice there's this EN, that stands for enable, DN stands for done. So there are actually two bits that this command will output. They are the enable bit and the done bit. Now, did you notice that when I named the timer, I named it T4:0, and it looks like something's missing because you're used to seeing an address like this, I:0/0. Okay? There's nothing after it. There's no slash anything here. So what's going on? Well, T4:0 is all of the data that goes with this timer. If I want to talk about the done bit or the enable bit, then what I would do is something like this. T:, and notice I'm dropping the 4 because it's redundant, 0/DN. It's not bit 0, it's not bit 1, it doesn't matter, it's the done bit. And then there's also the enable bit, the EN bit. Now what is the enable bit? Well, the enable bit is just basically the conditions in front of the command. Okay? So in other words, if the conditions in front of the command are true, then the enable bit would be true because the timer will be enabled in order to count up time. Does that make sense? So what are my conditions for the right red light being on? Well, I would want to know the timer is enabled, and what else? I would also want to know that the timer is not done. See how I did that? I would want to know that the timer is enabled and running, and that it is not done. In other words, the accumulation value has not reached the preset. Because what will happen is, when 30 seconds have gone by, the accumulated value will be at 300, the done bit will come on, and if the done bit comes on, then the opposite of on is off, and the right red light would turn on. Does that make sense? So let's try it and see if it works. Ideally, the right red light will come on for 30 seconds. There we go. Now, notice the right red light is on. The timer is running. It's counting up time. It is enabled. It is not done. Therefore, the light is on. When this reaches 300, the done bit will turn on, which the opposite of on is off, and the right red light turns on. This is not the only way to solve the problem. When I show you guys a solution to any of these problems, remember, please, that it's not the only way. There are multiple solutions, because this is essentially a design problem. There's always multiple solutions for design problems. Well, that worked fairly well. Now it'd be nice if I could turn on the green and the yellow lamp. So if I look at my timing diagram, the next thing to turn on is the green lamp. Now we want the green lamp to be on for 25 seconds, and since we've used this timer we can't, it's done, then we won't be able to use it to enable the green light. Notice it's not counting up time anymore. So I guess we need another timer. Now, it turns out you can use a single timer, like I said, and I'll show you how to do that later. Right now, I just want you to learn mainly about timers. So I'm going to put another timer in here. What a T-on timer does is it delays the amount of time before something comes on. That's what it technically does, because basically, it does not give you a done signal until it's done counting time. And usually you trigger an event to happen based on the done signal. Okay. I'm triggering something to happen before the done signal is complete because I've got multiple things to trigger. I've got multiple lights to turn on. So what I'm going to do is cascade these. I'll have to give this one a new timer number. I cannot use timer 0 because timer 0 is already being used. If I put timer 0 in here and started changing the preset value, it would change the preset value here as well. So I have to add a new timer, and let's set the preset at 250 because this is going to be the green lamp timer. Now I'm going to do something else. I'm going to add some comments. I'm going to right-click the timer instruction and add red timer or right red timer and right green timer. Okay. Now remember, you can always go on Blackboard and download my programs when they're done if you want. What's that? No, because we're gonna make, what we're gonna do is we're gonna make these operating series. I'm not trying to program both sides at the same time. I'm just trying to get the sequence set up. Good question. Anything else? I do not want to operate the left side at all right now. I want to operate the right side. Now the problem is that this right green timer is going to start running immediately when the program runs. So what I really wanted to do is to wait and run when the right red timer is done. So I'm going to put a set of contacts in front of it that say when the right red timer is done, then activate the green timer. So here we go. It's actually the same address that I've already used. So what this says is when timer 0 is done, then this run will go true, and this timer will start accumulating time. Okay? So let's see what happens. In fact, before we see what happens, why don't we rearrange our program a little bit? I'm going to take this one up, and you see the Logix Pro has some nice bugs. You see what just happened? Completely destroyed that run. Try again. Now I've got to recreate it, but that's not a big deal. When that happens, the time when it hurts when that happens is when you've got 20 lines of code and or more. You can't see it all at once, and a line disappears, and you didn't know it. Okay, so please save your Logix Pro code often. It'll serve you well in the long run to do so. And I'm going to take my own advice and say, okay, I'll put it on the desktop so I don't forget to put it on Blackboard for you guys. All right, now I threw in another rung so that I could control the green lamp. I'm going to label it so I know what is, which thing is what. And basically I'm going to use the same idea that I used for the right red light, but I'm going to reference the green timer instead. Let's see if this code makes any sense. When the program starts, this timer is going to be enabled. Once it's done, then let's see, then that will enable this timer. When this timer is enabled and not done, the right green lamp will come on. So this should work. Except for one problem, the right red timer is already done because I already ran the code. So what I'm going to do is change the accumulated value to 0. Now I can do it here, I can double click and change it, but I'm not going to. I want to show you how the timer stores its data in memory. So if you click on the hammer and the wrench, and go to the timers file, okay, by selecting the table, T4:timer. There's a data table. You get there by the hammer and the wrench button up there at the top. I can't reach it. And then select the timer file. What you'll notice is that you cannot change, bring this down here where I'll be able to reach it. You cannot change the display. You can't change it and make it in binary or octal or hexadecimal or any of those things. You're stuck with what you've got. There's a reason for that. That's because the timer number doesn't necessarily correspond to one word. In fact, this timer 0 has 3 words associated with it. 3 16-bit numbers are associated with the timer. Remember, one of them is the .acc value, the accumulated value. That's what's displayed right over here. The other is the preset value. Now, both the accumulated value and the preset value are 16-bit numbers. So this timer can time up to 65535 units of time. Does that make sense? So 65535 tenths of a second would be 6,503. No, 6,553 seconds worth of time. Almost 4. So anyway, those 2 values are stored here, and then 3 bits of another word are displayed here. The done bit, the enable bit, and the TT bit. The TT bit stands for timer timing. So if the timer is in the process of timing, in other words, if the accumulated value is less than the preset value and the timer is enabled, then the timer timing bit will be on. Does that make sense? Now, if you think about it, the timer timing bit would have probably been a better bit to use rather than timer enabled and timer not done. Because timer timing is really the combination of those 2 conditions. Okay, so let's try that and see what happens. So that'll make our code a little bit simpler. But I wanted to show you the done bit. So basically, I'm going to replace enable with TT in both places. And back in the data table, I'm going to double click on the accumulated value of timer 0, clear it. That way when I run the program, the timer's not done. We'll fix that in the program a little bit later. Run. And I forgot to clear a bit. Hang on. Go back into the table. The timer's still done in memory, so clear all this out. Now, what I just did there, clearing all that, you should have done by I could have done by hitting simulations, reset timers and counters. And that would have reset them all. That does not clear the preset values. Preset values stay. But that does clear all the timers and all the counters. And the option was here, simulations. There's not just reset simulation. Reset simulation resets this side. There's also reset timers and counters, which resets the accumulated values and the done bits and the enabled bits and all that stuff. It's handy. Oh, you don't have to go into the data table and do so much typing. Okay, questions so far? We'll download this and run it. Okay, so we got the red timer running. The timer timing bit is working well so far, it seems, because it's triggering the red light to be on. So the light is good, it's enabled and not done. Once the accumulated value reaches preset, timer timing should go off because it's no longer timing, and sure enough it did. Red light went off. The green timer started because the red timer is done, so that triggers the green timer to start. It's enabled, it's timing, and so the green light is on. Reach 250, it's done, and green light turns off. Car still zipping through the intersection. Right? Free for all, the light's not working. Just honk really loud and hope you make it. Okay. All right, now it's pretty easy to extend this to include the yellow light, right? All I need is another timer. I need another condition for running that timer, which is just that the green timer is done. I'll need a new timer number. And preset will be 50 to represent 5 seconds. Put a timer timing bit here. I just broke my rule. I should have inserted another rung. But I have a bad habit of dragging and dropping the command onto the end line. And most of the time, Logic Pro knows how to interpret that properly, but sometimes it doesn't. I dragged that address to the wrong place. Do timer 2 timing. All right, let's simulations, reset timers and counters. Download, run. And unfortunately, we have to wait for a full minute, so you get the chance to watch the code and understand what's going on. There's the green lamp. Everything seems to be going fairly well. There we go. Okay, so we have the yellow lamp on for 5 seconds. You may have missed it. It didn't last very long. Now, I'd like for this to operate on a cycle. I'd like for it to start over. And so far, what we've done is said when a timer is done, then trigger the next timer. So what about this idea? What if we take the done bit from this timer and use it to trigger the red timer? Okay, let's see what happens. Let's see, so when the timer is done. Okay, let's reset the simulations. And I actually meant to reset the timers and counters. There we go. Download, run, and nothing happens. What's wrong?
It's not done?
Yellow's done? Yellow's simply never done. And I forgot to comment my code, I'll fix that in just a minute. Yellow's never done, and so the red timer never starts, right? Okay, so what can we do? Do we use the enable bit or the timer timing? Well, if we use timer timing, that wouldn't really help us. Enable doesn't help us because this one never starts, right? I mean, if we were to put, if we were to use the enable bit, we might think we could use the enable bit of this timer and say when it's not enabled. Let's try that and see what happens. Do a little clever here and see if that works. Change it and reference the enable bit. The idea is that timer 2 will not be enabled when the program starts. So that'll start the red timer, red drives green, green drives yellow, and then yellow times. So let's see if that works. All right, let me comment my code before I forget it. So write yellow timer. And let's edit all these symbols. This is right green timer done. This would be right red timer done. Right red timer timing. Right green timer timing. Right yellow timer timing. This one was the right yellow. Really, it's the right yellow lamp, so I guess I should edit all these symbols and add the word lamp. And then this one is the right yellow timer enabled. Download it, run, red lamp starts. That's a good thing, because the yellow timer was not enabled. That's good. So we flush the lamp, we get red. 30 seconds pass, and got green. That's good. So far, so good. Green lamp's on for 25 seconds. Once that's done, that ought to trigger the yellow timer. Oh, we went directly to red. Did you notice we skipped yellow? What happened? what happened was the right green timer was timing, and when it was done, it enabled this timer. Once this timer was enabled, remember the PLC is not going line by line. It's scanning through this time after time after time. So it's scanning, it checks all this, okay, timer's still running, it's not done, go back, keep checking. So what happens is, once this bit is enabled, the PLC automatically continues back to the beginning. It actually, once it's enabled, it goes to the next line, evaluates it, and then jumps back up. And says, oh, look, that yellow timer is actually enabled. So the opposite of a 1 is a 0. Okay, unenable this one. Well, what that does is that clears the done bit. And once the done bit is cleared, this one clears its done bit, and once its done bit is cleared, this one's no longer enabled. And it just kills it. So we've got something that's valuable here, and we've got a problem. What's valuable is that we managed to get the cycle to start over. And you notice, it's been running this whole time I've been talking. But unfortunately, all we have is red and green. So we have to have some other way of taking care of this problem. I'll show you a really easy way to take care of it. Basically, what we want to have happen is when this timer, this right yellow timer, when it's done, we want to have the red timer reset. Okay, we want it to start over. Turns out there's a command to do that that's really handy. It's called the reset command. So, let's see, go back into the command palette. Timers and counters, that's what this RES stands for at the end. It's a reset. Okay, there's 3 types of timers. There's 2 types of counters. There's a count up counter and a count down counter. We'll get to that in just a minute. Right now we're talking about time. There's a time on, which you use most of the time. There's time off, which basically what you do is you set a certain amount of time. Well, I won't, it's just the opposite of time on. But RTO is more interesting. RTO is a retentive timer. See, what happens is, as soon as one of these T-on timers shuts off, what it will do is it will automatically reset the accumulated value and start over. So that when you re-enable that timer, it starts from 0. A retentive timer doesn't do that. A retentive timer does not clear the accumulated value even when it's not enabled. Okay? That way it can store time and continue counting later if you want it to, or continue timing later. So let's see. We're going to try a different command. Instead of this command, we're going to get rid of that. We're going to add in another rung. I'm going to save before I forget it. You know what? Let's do this. I'll just call this traffic signal 2. I try to save the evolution of the program a little bit for you. Anyway, put in a new rung. And what I'm going to do is use the reset instruction. What I'm going to do is reset timer 0, T:0. Now I could reset the accumulation value. But if I reset the whole timer, I know I'll get the done bit, I'll get the accumulated value, I'll get the enable, I'll get timer timing. All that will be clear. So let me just do that. But if I wanted to reset just the accumulated value, I would add .ACC. You haven't seen the dot terminology. A slash says that what comes after it is a bit. A dot indicates that what comes after it is a whole word of data. Does that make sense? Now I could reset the .PRE value. I could reset the preset value of any of these timers with this command. All I have to do is type in .PRE right now. But if I don't type anything, it will assume that what I mean is I want to reset the accumulated value and all the bits. Okay? Now, if I run this program, it's just going to automatically reset the first timer over and over. To break the idea that may still be lingering in some of your minds, that this goes line by line, I'm going to run this code as it is. Okay, and I'm going to show you that nothing will happen because every scan, which multiple scans happen every second, every single scan, the first timer is reset. Now, why the red lamp's on even though the timer's not timing, I'll explain in just a minute. But notice what's going on is the PLC is going through all 6 lines of this code multiple times per second, evaluating the outputs. So it'll evaluate this line, for example, remember whether or not to run that output, go to the next, update the timer, go to the next, check that output, it needs to turn on, it does, it needs to drop, it is, and then it goes here. So every time it goes through this code, it resets the first timer. So what's happening is that first timer is only getting to run for a very short period of time, because the scan's frequency is very high. The period is fairly short. So anyway, the reason that the timer timing bit appears to be on, because notice the red lamp is on, is because it actually is. Now, you don't see it on here because that reset instruction resets it so quickly you never get to see this light up. But after this first rung is evaluated, as the PLC is going through it, you realize, okay, that timer is on, therefore it's timing, that's true, therefore set the right red output. Okay? And it stays on. And very quickly it comes all the way down and says, oh, reset the timer. Okay, I'll clear the accumulated value, clear all the bits, which includes the timer timing bit, and yet it has already calculated that that output should be on, so it leaves it on. Does that make sense? So if this program is still somewhat of a mystery to you and how the red lamp's on and the timer doesn't appear to be running, you need to think about this as the program being evaluated over and over and over. It doesn't wait at one line like you do in normal coding. Okay, so how am I going to fix this? Well, I have to have some conditions, right? And basically, I need the right yellow timer to be done before I reset the first timer. So let's just add a set of contacts. It references timer 2's done bit. So when the yellow timer is done, the right yellow timer is done, then we'll reset. Let's download that, run, and see if it works. Okay, so that's 18, 19 seconds elapsed. 25, 26, 27, there we go. Changes to green, that's good. I'm going to scroll down in the code a little bit so that you can see the rest of it. The rest is going to happen pretty quick. So the yellow timer is on, it's done, and resets the red timer. Okay? So that makes it start back over again. So this is a loop, it's a cascaded timer system, but it's got a loop where basically you just, it's kind of like a deck of cards, right? If you build a deck of cards or a house of cards, pull out the bottom card, the whole thing falls. That's the way this is. That reset instruction just pulls out the bottom card and the whole thing starts over again. Any questions? Okay, how are we going to program the other side? We could do it the same way. We could use 3 more timers. We could use logic. Okay, you got to be careful here. You could use logic and say, well, when either right green or right yellow is on, then left red should be on, and that would be true. And then you might think, well, let's extend that, and whenever right red is on, then left green is on. The problem with that is that right red is on at a time when left green should not be on. Okay, so you have to be careful with that. Turns out, you could use 3 timers on one side like we've done here, and a single timer here to just differentiate between these two. You can actually do that. I'm not, because I want to be careful and not use outputs as input. So I want to use when the lamp is on as an input. Okay? Now you could be tricky and say, I'm not going to use that, I'm going to use the timer timing bits, and that would be okay. Okay, that I wouldn't complain about. But just to make life easy, I'm going to create the other half of this and then see what happens. Okay? So if I were to recreate this just as it is with a red timer for the left-hand side that starts by itself, that would not be good. Because what would happen is both red lamps would be on, then both green, then both yellow. That wouldn't be very effective, right? It would be kind of like, has anyone ever seen Beavis and Butthead? Did you ever see the one where, I'm not a big fan of them, but there was one thing that I thought was funny. There was some natural disaster, and of course the do-good teacher was trying to help direct traffic because there'd been an earthquake or something. He needed to do other things, so he said, come over here and help me. So, you know, he got one standing one way to direct the traffic and another standing the other way, and they're not looking at each other, of course, so they're both doing this. Oh my God, you know, there's crashes happening behind us. Yeah, so that's not what we want in this case. So what lamp should start? If the right red lamp starts off, what left lamp should start off? Great. So let's just do that. All right, I'm going to code this fairly quickly. Let me save it. we go. I'm gonna code it, and then I'm going to, save it as traffic signal free. All right, so I'll need a couple more timers. In fact, I'm gonna cheat just a little bit. I'm gonna show you some tricks. I'm gonna right-click, copy the rung, and then I'm going to right-click, paste rung above. Once again, Logix Pro is buggy, and this does not always work. All right, now I'm going to change this and we've used timer 0, 1, 2. Now I have to use timer 3. Preset will be 250 because it's going to be the left green timer. Okay. And then I'm going to grab the, so that I can minimize my effort in renaming, I'm going to copy the rung that already dealt with the green light. I'm going to paste it above the last rung. And I'm just going to drag the address for the left green lamp, change the comment, and I don't want to reference right green timer timing. I want to reference left green timer timing. That will be timer number 3. Notice I don't change the label before I change the address. If you change the label before you change the address, it'll change all the labels on all of the instructions like that, all the addresses. So you got to change the address first. So this would be the left green timer timing. Okay. Now, a lot of times I recommend that after you've added a rung of code that you run it and check it to see what happens. Now, I'm confident enough that I think I can add 4 more rungs and get the whole thing to work. Okay, so I'm just going to do it, and hopefully everything will go okay, but I may get them making a mistake, so we'll see. All right, so here we go. What comes after green? Well, yellow comes after green. And I'm going to put this code in order so that it would make sense to me if I was trying to read it a month later after I've forgotten how I did it. Okay, so paste rung above. I've got another timer. Another timer instruction will have to be timer 4. It will be a yellow timer, so it should have 5 seconds. But it is the left yellow timer, not the right yellow timer. It should be triggered after the left green timer is done, so that's timer 3. Okay. And we have just a little bit more. We've got 2 more runs. Well, 3 more runs because we have to reset. All right, where are we? We've got green, we've got yellow, we need a red. So let's copy the first rung. And paste rung above. This will be timer 5, so that's 6 timers. Red timer, so we need 30 seconds. And I need a set of contacts. Oops. Let me show you what I just did. You may want to pay attention to this. I right-clicked this instruction and I hit cut. I didn't intentionally, I intended to copy it. So I went over here and I right-clicked this instruction and said paste left. Okay? And then what my intention was just to copy it, right-click this instruction and paste left. That way I've got a timer timing fit, or referencing the timer timing fit of the previous timer. Anyway, so this is timer number 4, and it is the left yellow timer. Now, seems to be, yeah, I've forgotten the yellow lamp and the red lamp, so let me copy those lines. Where's the yellow lamp? There it is, right yellow lamp. I'll copy that rung. I'm going to paste it below the timer on the previous rung. I'll reference the yellow timer 4. Let's see, left yellow timer timing. When that happens, I want the left yellow light to come on. And this should be the done bit, not the timer timing bit. So when the left yellow timer is done, then that should trigger the final left red timer. So let's see, left, red. Now in all of that, I probably made a mistake. So I probably should have tested my code as I went, but here we are. Let's see, there's one more thing I need. I need to turn on the left red light. I need to save also, so let's save this as traffic signal 3. So let's see, green, yellow, I need red. Here's from above. Red is on 2/0. That's the left red lamp. And let's see, looks like I need some comments here. This done bit comes from the left yellow timer done. And this would be timer number 5. And that's the left red timer time. See if it works. Yep. What happened?
Car crash?
Well, fortunately, I don't have, yeah, car crash. Fortunately, I have not unparked the other one. Do you want to unpark the other one? We had to do it. Okay, so why? Okay, so what happened? Why did the two green lights start together? Is there a mistake in my code? Something's wrong. What happened was I did not reset the timers. Okay, so let's try that first. Simulations, we gotta go to program. Let's reset the simulation so that we don't have any crashed cars sitting in the intersection. And once we've done sound effects, then we'll reset timers and counters. Tell the wizard to get lost again. The lights come back. Download, run. Now it started out okay. All right. Now this really highlights one of the problems with my code. Really, the timers on either side are independent of each other. Since this is a computer, since it's a digital computer and it should in theory never get out of sync, then this should work okay, assuming that the timers are always reset at the same time. But that gives me an idea. Maybe to ensure that both sides are always in sync with each other, maybe it would be a good idea, remember that reset instruction? When that reset occurs, maybe it would be a very good idea to reset the other side at the same time. Okay? So with this reset instruction, once the right yellow timer is done, that's when the left-hand side starts over too, see? It's right here. The left yellow timer is done. We need to restart on the left anyway. So why don't we reset the green timer on the right hand side? I'm sorry, on the left-hand side. Okay, so hit program. I don't know why I said it. Give us a sound effect. What I'm going to do is add a rung or a branch around this reset instruction so that I can put another reset instruction down here. And I'm going to add the address of the left green timer. And what that will do is whenever we reach the end of this cycle, that'll reset both the right red and the left green timers. That way it doesn't really matter if I don't remember to reset timers and counters, it will always just work. Download, run. I thought it would work. Honestly don't know what I did wrong. Right yellow timer done. Oh, I know what I did wrong. I still didn't reset everything. If I run it, it'll actually work on the next cycle. What's going on is that I forgot to reset the timers, and so that the right yellow timer done was still true for one cycle, and that messed up everything. It reset my. Actually, no, it didn't, because this one's not reset. Oh, it was enabled when it was done. Well, anyway, if I do this once, it should stay in sync. Let's run it and see if it. I don't know what I've done wrong. I've got to figure it out.
Yeah, but you can't reset the counters.
Oh, I hit the wrong button. Yep, thank you. I hit the wrong button. Now, if I let it run and it went through one cycle, let me show you. See if I can get it to mess up again. After it runs through one cycle, it should restart, because once this is triggered, that'll reset everything. Okay, we've got a problem, both red lights are on. That should not have happened. And that shouldn't happen either. So I've got a big bug in my code. Fortunately, it's about time to take a 5-minute break so I can figure out what I did wrong. It's hard to figure out what I did wrong when I'm sitting here in front of you guys, so. Now I've got to recreate it. Again, I'll be able to discuss what I did wrong. So I probably should have added a few lines at a time and ran it to see how it worked. Please take a 5-minute break, come back, and then we'll